Hello, chemistry students. This is Doc BP here to explain how to do homework number 3, where we were drawing Lewis dot structures of covalent compounds. These ones were level 2. It was a little bit trickier to do these, so let's walk through these together. So first off, we have slides 1, 2 through 4 were the examples that I did before. So I'm going to start with slide number 5. Remember, we're going to need our periodic table handy. So here's my periodic table handy. SiO2, one Si, two oxygens. Because there's just one Si, it goes in the middle. The oxygens go on the outside. How did I find these dots for these ones? They came from Si, which should have 4 dots, and oxygen, which should have 6 dots. So that's why I have 2, 4, 5, 6 around both the oxygens, and the Si has 4. Notice on the oxygens, I've drawn those single dots as close to the silicon as possible so that now I can connect those dots. I have one bond here, another bond here, another bond here, and another bond here. So now what this looks like is Si with 2 bonds to the oxygen and Si with another 2 bonds to this oxygen. I'm going to pause this and clean it up for you. This is what it looks like when it's been cleaned up. Si has 2 bonds to this oxygen. Si has 2 bonds to this oxygen. The oxygens both still have their lone pairs that are non-bonding pairs. And here's the double check to make sure that you have the correct number of electrons in all of this. Remember, the oxygens had 6 electrons for one oxygen, 6 electrons for another oxygen, 4 electrons for silicon. So 6 plus 6 is 12, plus 4 should be 16 electrons total. So let's count down here. We have 2, 4, 6, 8, 10, 12, 14, 16 electrons total. The second check is we want to make sure that all of the atoms have 8 electrons shown to complete their octet. 2, 4, 6, 8 for oxygen. Now silicon is next to 2, 4, 6, 8 here, and this oxygen is next to 2, 4, 6, 8. Everybody has 8. We have 16 electrons, looking good. The next one we have OH with a -1. Remember we have, oops, what am I doing? We have, I don't want to do insert. Counting electrons. We have 1 oxygen, 1 hydrogen. Oxygen has 6 electrons. Hydrogen has 1 electron. But that -1 charge tells us that there's an extra electron. So there should be a total of 8 electrons here. So let's see what's happening. We have oxygen that has 2, 4, 5, 6. Hydrogen that has 1. So that's 2, 4, 6, 7. We need 1 more. Because we're going to show a bond happening between O and H, I'm going to show that bond in now. So you can see that these 2 ones are not alone. So oxygen wants that extra electron here. That is our OH, and we're going to give it a -1 charge here. A -1 charge to show that this whole thing has a -1 charge. There's our OH. We can clean it up a little bit. If we clean it up like this, now we can show that oxygen has 2, 4, 6, 8 electrons, and hydrogen just has 2 electrons. Remember, hydrogen is little. It only wants 2 electrons to have its octet complete, to have its total valence shell full. All right, that's slide 6. Now let's try slide 7. Here we have 2 nitrogens, N2, 1, 2. Each nitrogen has 5 valence electrons. So if we're counting up our total, we have 5 plus 5 equals 10 valence electrons total. So now let's bond these ones. I have written these like I would from our last chapter with 2 on the top and then 1 on each side. But to show that these 2 are not going to bond at all with each other, I'm actually going to rearrange these. I've rearranged them so that all of our non-bonding pairs are far away, but the single electrons that want to bond with its neighbor are closer to each other. So now I'm going to connect the single dots. Here's 1 single dot getting connected. Here's 2 single dots being connected. Here's 3 single dots being connected. So there are 3 bonds in between those 2 nitrogens. Here's what it looks like when it's cleaned up. When it's cleaned up, we have 2 nitrogens, 2 unshared pairs on each nitrogen, and then 3 bonds in the middle. Let's count to make sure we have 10 electrons total. 2, 4, 6, 8, 10, because each of those lines, each of those bonds counts as 2 electrons each because we connected 2 electrons. And this nitrogen has 2, 4, 6, 8. This nitrogen has 2, 4, 6, 8. Everybody's happy. Let's try the next few. Starting up, carbon has 4, each oxygen has 8. Again, I've drawn those single ones next to each other. Let's go ahead and connect those ones first. So I've got a connection there. I've got a connection there. I've got a connection here. All right, and carbon wants one more. You can do it to either one of those ones. So I'm just going to pick the one on the left because that's fine. So we've connected those single electrons, all of them from carbon and some of them from the oxygens. But here's the problem. This one and this one are still by themselves. So this is where that charge comes into account. Let's count up how many electrons we should have. So there's 1 carbon, so there are 4 in the carbon, and there are 3 oxygens, so +6, +6, +6. 3 oxygens, each of them 6 electrons, 1 carbon, 4 electrons. That -2 tells us that there are 2 extra electrons. 2 extra electrons. So how many is this total? 4 plus 6 is 10, 16. 16 plus 6 is 22, 23, 24 electrons total. So let's count. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 22. We just have 22 electrons. So this is where these extra 2 come from. We're going to put in these 2 extra electrons, and we're going to pair these single electrons in oxygen. Remember, no electron likes to be by itself ever. So it's either going to come in a pair already because of the valence electron dot structure of the original atoms, or we're going to add an extra one because of the charge to make it paired. So here is our structure. We're going to give it its charge, and then I'm going to clean it up. So we have, looks like this, and now we have a -2 for the total thing there. Okay, now I'm going to clean it up. Here's what it looks like cleaned up. We have carbon with a double bond to oxygen, carbon with a single bond, carbon with a single bond. This oxygen still has its lone pairs. This oxygen still has 2, 4, 6 electrons in lone pairs, 2, 4, 6. Now let's count up the total electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We meet our total number of electrons, 24 total electrons. And we want to make sure that all of the atoms have 8. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And we show our formal charge there. I'm going to do the last 2, just show you the cleaned up copy. For this one, we had phosphorus in the middle and 3 oxygens. Phosphorus started out with 2, 3, 4, 5. Oxygen started out with 6 each. But because we had a total of 3 extra electrons because of that -3 charge, each of those oxygens, the lone electron that needed a friend, each of them got an extra friend. So this is what PO3 looks like. Remember to draw on all of the extra electrons in the outsides of oxygens to show that -3 charge and to make sure that all of those have 8. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and that there are 26 total. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Everybody's all there. All right, next one coming up. This one started out a little bit trickier. First, you have 1 oxygen and 3 hydrogens. The oxygen started out with 2, 4, 5, 6 electrons, and each hydrogen had 1 electron. But notice this +1 charge. That means that there is an extra Sorry, that it's not an extra electron. The electron got taken away. The plus one charge means it has fewer electrons. So in our total, we're going to subtract one here, subtract one here. So our total should be 6, 7, 8, 9 minus 1, 8 total. To show that that electron is being taken away, what I'm going to do is take away one of these electron pairs. I'm going to show this pair now as a single electron there to show that one of those in the pair got taken away. Now we have our total of 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. That's what that plus one charge does. It takes one of those electrons away, so now everybody can be nice and even and completing the octet. So I'm going to connect those dots. I'm going to connect these dots. And I'm going to connect these dots. And now everybody's bonded. We need the formal charge. So it has a charge. And now I'm going to clean it up so it looks prettier. Here's our H3O plus 1 oxygen, 3 H's. There's a total of 8 electrons because we took away that one extra electron. So 2, 4, 6, 8 total, showing that plus one charge because we got rid of an electron. Oxygen has 2, 4, 6, 8 that are being shared or kept by itself. Hydrogen has 2 shared. Hydrogen has 2 shared. Hydrogen has 2 shared. Everybody has an octet. All of our electrons are there. Hopefully this helps. Email me with questions.